I've recently had a message sent to me asking me a whole bunch of questions around reverse swing doors. So Kevin's asked me, when is it suitable to use pressure sensors on a system? When is it suitable to use reverse hung doors and feathering of the door, as in the door gets pulled open partially for make-up air by the fan? When is it suitable, if at all, to operate a door actuator on the stair door to fully open for make-up air? Which of the above methods is best, efficient, safest? Is it all down to the fire specification and strategy for each project? Is there a guidance document that covers this in that industry that I'm not aware of? I'm not sure whether this is a suitable subject for a 2-Minute Tuesday video, as it may be too big a subject, but I would welcome some clarity if possible. Lots of questions, sorry. Well Kevin, you've come to the right place, but wow, that is a very big topic. So I'm going to go and get a cup of tea, and then we'll go through your points and explain why reverse swing doors should be used wherever possible. Whilst I'm getting my tea, you should be hitting subscribe on YouTube. If you need the link, it's in the description. Be right back. Let's make a start. I'm actually going to start with your second question and explain what reverse swing doors are and why they should be our first choice when designing a mechanical smoke ventilation system. Firstly, what door are we talking about? The door we're talking about is the door from the protected lobby or corridor into the staircase. The reason this door is a fundamental point of discussion in smoke control is that it's the gateway between the protected corridor and the protected stair core. In a typical pressure differential smoke control system, air is extracted through a damper in the protected corridor, drawing make-up air down the stairs via a head of stair vent and into the corridor via the door. It's worth noting that guidance states that if make-up air is coming from the stair, you can't have a vent or damper from the corridor into the stairs. You must use the door. This make-up air does two things. Firstly, it stops the zone becoming too depressurised, which would mean that the apartment doors will be sucked tight shut. Secondly, as the make-up air comes rushing through the door, it creates a flow of air that stops any smoke in the corridor travelling into the stair. Often in buildings, the door is designed to open into the staircase in the direction of evacuation. A little later I'll explain why this is usually unnecessary and not the best option. In a reverse swing door system, we're instead making the door open the other way around, into the corridor. This is so as the fan begins to suck, the door is pulled open and the make-up air comes straight down the stair core and through into the corridor. Doing it this way is best for these reasons. Firstly, it keeps the stair core free of smoke very effectively as it's drawing fresh air down the stairs. Secondly, it ensures there's no pressure build-up in the corridor. This is really important, as with a mechanical system, you have to ensure that apartment doors open with no greater force than 100 newtons at the door handle. That's BS 991 2015 14.2.4. Otherwise, you can essentially lock people in their apartment with no way to escape. I've made another video about this, link below. Finally, it also means that the system can be run at one speed rather than requiring a means of escape and a firefighting speed. So the system can just run at firefighting speed, which means that the firefighters do not have to alter the smoke control extract speed when they turn up, which is really helpful, as most firefighters aren't trained how to do this, and fiddling with controls isn't something they want to be doing when they've got a burning building to deal with. So, what are the alternatives to a reverse swing door system? Kevin, this bit is about the pressure sensors. As an alternative, the door is hung to open in the direction of travel, and the differential pressure sensors are fitted to ensure the corridor doesn't depressurise to a point that would cause a force greater than 100 newtons at the apartment door handle, somewhere between 25 and 50 pascals. If the stair door is open, the system will run at full speed. However, when the stair door closes, the system has to go into setback mode, which reduces the fan speed to make sure that the apartment doors can still be opened. Make-up air comes from air leakage, for example, from apartment doors and lift cores during setback mode. The system must react within 3 seconds of a change in pressure. This alternative method is significantly less suitable for the following reasons. Firstly, the system is much less effective at clearing smoke when running in setback speed. Secondly, there is much less effective stair core clearance as fresh air isn't being constantly drawn down the stairs. In this scenario, any smoke that gets into the stair is likely to stay there until the door is opened again. Finally, there is a risk of the pressure sensor failing. If that were to happen, you would end up locking people in their apartments. So your next question may be, why don't we always use reverse swing doors then? The answer to that question is found in Approved Document B 3.94. The door of any doorway or exit should be hung to open in the direction of escape whenever reasonably practicable. It should always be hung to open in the direction of escape if more than 60 people might be expected to use it during a fire. As you can see, if there are less than 60 people likely to use the door in the event of a fire, which is usually the case, it is possible to use a reverse swing door. It is our ethos that the inconvenience of the reverse swing door is far outweighed by the greater effectiveness of the smoke control system. Additionally, when a reverse swing door system is in operation, the door is actually pulled open, which could make egress even easier. There are other alternatives though, one of which is what's known as a floppy door or a double action door. Evacuees can exit in the direction of escape, and the smoke control system can draw the door open the other way to avoid pressure buildup. These are what you might consider a win-win situation, however they aren't always favoured due to the extra cost that these doors can involve. The other alternative is to not take make-up air from the stair at all, but instead from another source. However, drawing air down the stair is one of the best ways to keep it clear of smoke. So to finish off, Kevin, here are some thoughts on your final questions. When is it suitable, if at all, to operate a door actuator on the stair door to fully open for make-up air? Whilst you may occasionally see an actuator on a stair door to hold it fully open for make-up air, this would be as a result of a very specific set of circumstances in a fire-engineered solution and should not be routinely used. This is due to the fact that if the smoke control system were to fail, you'd be left with a stair door stuck open, which would result in losing the stair core. It should also be unnecessary, as like I mentioned before, when a reverse swing door system is in operation, the door is already pulled open by the suction of the fan set. Is it all down to the fire specification and strategy of each project? Yes, it is down to the fire strategy of the building and is nearly always part of a fire engineered solution. Is there a guidance document that covers this in our industry that I'm not aware of? Yes, the SCA guide mentions this on pages 41, 45 and 46. Kevin, I hope I've answered all of your questions. For everyone else watching, I hope you found it interesting too. If you didn't subscribe while I was making my tea, then make sure you go and do it now. Thanks for watching, and as always, I'll look forward to seeing you next week. Bye for now.